In the next few videos, we're going to learn how to design with lists. That's going to include changes to both the how to design functions and how to design data recipes. Now, the way I'm going to present those changes is different than I used to originally cover those recipes. What I'm going to do, starting in this video, is charge into a data design problem with lists. And when I get to a place that I don't know what to do, that the recipe doesn't already tell me what to do, I'm going to make a lucky guess, and it's all going to work out fantastically. I'll do that with the data recipe in this video, and I'll do it with the function recipe in the next video. And then in the third video, I'm going to go back and explain why those lucky guesses really were the right guesses, and formally include them into the recipes so that you'll be able to design with lists systematically from that point on. This problem has to do with designing a program that's going to keep track of your favorite Quidditch teams. So we're going to design a data definition to represent a list of Quidditch teams. Remembering always that when we design data definitions, what we're doing is working out how to represent information as data. Let me just do a couple comment boxes here. And in this box, we'll put some examples of the information. So I'm going to focus on some of the Canadian Quidditch teams, one of which is UBC, one of which is McGill, and one of which is the team who must not be named. And by that I don't mean Toronto, I mean a team that's actually chosen that name, which I think was a little silly, but never mind. So now let's think about the data that might be used to represent that. You know, those things look a lot like strings to me. Strings look like a good way to represent that. So for example, you might represent the team UBC as the string UBC and so on. So that's how we might represent some individual teams. Now, how might we represent a list of teams, right? A list of my favorite teams. Well, we saw how to do that using conses. I would say cons. Let's suppose that my two favorite teams are UBC and McGill. That's kind of how we would represent that using lists. So now I've thought some about the information in the data, and I'm ready to go ahead and write out the actual data definition. So let's see, what I've got here is kind of a list of string. Every element of this list is a string. So I'm going to go ahead and call the type list of string. Now I could call it list of team, but I'm going to call it list of string. We'll see some examples where you'd introduce another type name, for example, team. We'll see some of those a little bit later this week. So I'm going to say list of string is. Now, here there's an interesting little thing, which is here's one list of favorite teams, and the rest of that list is a list of favorite teams, and the rest of that list is also a list of favorite teams, but it's an empty list. So buried in the midst of here is this subtle point that empty would also be a good example. Let's just suppose you didn't like any of the current Quidditch teams. Your list of favorite teams, not with a quote there, empty like that, would also be an example. So the way I'm going to write this type comment, and again, we'll come back to this. Remember I said I was going to kind of get lucky a few times in this design, and then after the data design and the function design, I'll explain it all. The way I'm going to write this type comment is like this. I'm going to say that a list of string is one of either empty or cons string list of string. Now there's an interesting thing going on there, which is that in the middle of this type comment, I refer to the type comment itself. So I'm defining list of string, and in the middle of it I refer to list of string. And we're going to talk a great deal more about that. I'm just pointing out that that is there. When you see that, that's what I mean to say. Let's do an interpretation. Interpretation, a list of strings, because each element in these cons is a string. And now let's do some examples. Well, one example is empty. And another example is, say, just McGill and empty. And another example, oops, that's not 1, that's 2. And another example is cons UBC, cons McGill, and empty. Before we go on, let's see if the type comment we have matches the examples we have. We're going to talk more about the type comment in an upcoming video, as I said, but it's a pretty good question right now to at least make sure that the type comment admits the 3 examples we have. So let's try that. The value of LOS1 is empty, so the question we have to ask is empty list of string? Does empty match the type list of string? Well, let's see. The type definition for list of string is this, and there's 2 cases, so let's see. Does empty match the first case? Yes, it does. So now we know that empty is list of string. That wasn't that hard. Now let's ask about LOS2, which is cons McGill empty. Again, we want to ask, is that list of string? Well, here's the type definition for list of string. And there's 2 cases. Let's see, does cons McGill empty match the first case? No, it doesn't. Cons McGill empty definitely isn't empty. Let's try the second case. Well, cons McGill empty starts out with open paren cons, which is how the second case starts out, so that looks promising. And cons McGill empty has this closed paren at the end, which the second case also has, so that looks promising. Now the question we have to ask is McGill, is the second thing in cons McGill empty, McGill, is that string? Well, yes, McGill is string. That's trivially true. We know that McGill is a string. So because that's yes, we get a little bit more of a match between cons McGill empty and the second case of list of string. Now we need to ask the question, is empty list of string? Well, we've done this before, but I'm going to do it again just for completeness. So we ask the question, is empty list of string? We look at the type definition for list of string, and its list of string is one of, there's 2 cases, and empty matches the first case. So yes, empty is list of string. So going back into the prior matching, that means empty matches list of string there and there. So now we have a complete match, and we know that cons McGill empty is list of string. And I think you could see that this would work for longer lists. It would just get boring. If I had a list that had 2 elements in it, then I would end up having to go to list of string the first time, list of string the second time, and list of string the third time to get the empty at the end. It would just keep going. In some sense, what's happening here is that the self-reference in the type comment, the place in the type comment where list of string refers to itself, is letting us match arbitrarily long lists, because we just start the matching over with the rest of the list as many times as we need to before we finally get to the empty case. We'll talk more about this, the video after this next one. Now let's do the template. I'm going to say define fun for, and I'm not going to write list of string here. For these list of types, we're going to let you abbreviate it like this. And let's see. Template rules used. Now the template starts off easily enough. The first word after is one of, so the first rule is the one of rule. And there's 2 choices. So that means I'm going to put in a cond with 1 question, 1 answer, and another question and another answer, and that's the beginning of the template. Now let's see, the next part is easy. After the one of is an empty. So that's an atomic distinct empty, because empty is a single value. There's a single empty list. So atomic distinct empty. The predicate for empty is empty question mark. And it's an atomic distinct, so we just have dot, dot, dot in the answer. That's atomic distinct empty. Now, we have this case. And remember what I said, the way we're going to think about a cons is that a cons is compound data. So we're going to use the compound rule here. And if we go look at the data-driven templates page, we'll see that cons is one of the examples it gives for compound. So it's compound, cons, string, list of string. It's the last question of an itemization, so we can make the question be else. And then it's ... and the two selectors. Well, the selectors are first of LOS and rest of LOS. And the type of first is string, because it's a cons of string and list as string. So the type of first is string. And the type of the rest is list of string. Now here what I'm going to do, and I'm going to talk more about this, not in this video or the next video, but in the video after, I'm going to come back to this point. So now I'm going to kind of just do something. This is what I mean by getting lucky. I'm going to do something lucky. I won't explain why. We'll explain why in 2 videos. But I'm going to put this in the template right here. I'm going to run that template. There are no errors, so it's well formed. I'll comment it out. And now at this point I can delete this scratch work up here. And there's a data definition for representing Quidditch teams or lists of Quidditch teams using list of string. In the next video we're going to go design a function operating on these lists.